Hello, folks. I'm back, and this is part 5 of solving LeetCode problem 1920 build array from permutation. And I'm actually going to go ahead and code this out, the new solution that I have. This is the old solution where a new array is created and all that, right? I'm going to go ahead and write down the new solution. Before that, I just want to look at one thing, which is just check out if all of these are okay. Uh, some of the things to keep in mind are I'll write it down, but write it down here. Paperwork, I think paperwork is already there. Paperwork, well, yeah, I mean, these are just some examples, right, of different inputs, examples of different inputs. So here, when we say I is equal to 0 and the value is 0, we just put -1, then we go to I equal to 1. Uh, in this case, we store old values and then go ahead to 11 is here and then say 1 is 70 and we say I is equal to 11, right? So then next we can go to 11, right? Once we go to 11, we should store this only once. So there is going to be only one variable instead of having one map with just one key and one value. I'm just going to create one variable for key, one variable for value, that is index and then value, right? Index and old value, right? Given an index, it's old value. And it's kind of like this top point where you start here. If these two are not equal, you're going to stop here after going in some places. Like in this case, 111, let's say this is 1, you'll come back and you'll come to 1, right? Once you come to the stop point, you go to the next one, right? And you actually override the stop point with the next value and the stop point old value as the this value, and then go ahead with that, right? So whenever you come to the stop point, you're done, and you move on to the next one. And we have proved that whenever you start from one value, you have to come back to that value, no matter what. Um, and then you start from one value, you loop back to the value. For example, 111, 11, 17, 17, 16, 16, 1, again it goes back. So this, we have proved it actually. So I think we proved this over here, right? And so we have actually proved that if it starts from I and it ends at I, if it starts from I and goes somewhere and all, and then starts looking at X and not at I, um, then that is not possible, right? And we check, let's say it's possible, we actually prove that it's not possible. And we also say that uh, we start at I and end up at L, right? We don't end up in I or X, we actually end up in L, right? So is that even possible, right? L, which is a value down, and you go back to L, you've actually already passed through L. You're already like, you're saying basically it's the same thing as you go back to L and you start looping at L or something like that, right? So, and that you already passed through all numbers, this is also not possible. Uh, so we have proved all this. So based on this, we can actually write down a simple code, right? So let's go ahead and write this code. So here we'll actually remove ANS, right? And we're going to return only nums. And this is going to be messed up initially. Let's say we give this as the thing. Let's see how that goes. Array underscore test. Let's run this test and let's see if it works. But interestingly, one thing you'll notice is other than failing, you'll also notice that the input and output are the same, right? This you'll notice. Actually, um, actually the output is right. This is not the input, right? This is for test case one, this one, right? This is not the input. Actually, the input was 0, 11, 9 something, right? Interestingly, it has gone right for most of the way. Okay, there is two twos. I wonder why. Oh, there are three twos. Interesting. Anyways, but it did go right till here. After this, it went wrong again, right? In this case alone, I just want to do one thing. I want to say you give the input, okay. We'll give the cloned input actually. Um, or we'll clone it before it. Input before processing. Input before input cloned, right? Because if input is so, what can we say this? Input clone, right? Because or input before some processing, right? So I'll just say copy and have some destination here. Actually, this is called n and this say variable, variable integers, right? And we have, let's say this is the destination, right? So input before processing, and then you have sk's dot input outputs, right? And if n equal to sk's dot input outputs length, then you're good to go. Length of this, all good. If it's not, then it's a problem. Fail now or fail already. I think error is basically a call to fail and log it is equal to log and first log and then fail. Right? So we'll just say fail now, and can we say something here? No. So error, you can say something like error occurred while doing copy operation on input. Input is this, copied input is this, and then you say test case dot input dot nums, comma, input before processing is this. Let's see if the value is still the same. Basically, if you see the input is wrong here for test case index 1, the input is actually 0, 11 something. Here you see the output. Basically, input and output are the same, like they are pointing to the same array. That's the problem, right? So now if we actually run cloning and then we're sending it, so we actually use, we can actually use the clone. So input uh, before processing, right? And I can actually say index and then input before processing is input before processing, and let's see if we can actually click this and run this. So it says input before processing, nothing got copied. Okay, awesome. We have to actually make this. Okay, how come? Error occurred, copied input is this, okay. So this is error for 021 543 also, 534, and also for this, I think. And error occurred while doing power operation. Error in index test case one. Interesting. 011. And it also went ahead to okay. So error web is not like it does not fail now though. It's log f followed by fail, not fail now. I think you can just say fail now. Just say continue. Maybe. Yeah. If there's an error, if there's such an error, then we can just continue. Right. Go to the bottom also, and you can just click here and you can just go to the bottom. Cool. So error occurred while doing copy operation. Error occurred while doing copy. Awesome. So there is only one test result. So we can actually create multiple tests. We can actually say error. So this is failed, right? Already one failed. You're saying uh, this is again fail. We can create a new thing. One moment. So I can just say test cases and then say something like t dot run, right? And say something like fmt.println printf test build array and then percentage d comma index. Okay, and this is function. So I'll have this. Uh, okay, so this is actually a string. Um, can we just say plus or something? Plus index. Okay, that doesn't work. Okay, so plus. Oh, this works. Interesting. So this can be done anyways. So I'll just go ahead and say, hmm, string interpolation should be extra hard. Anyways, I'll just go ahead and do this. Test name is equal to fmt.printf and index, right? And use that as a test name. So I ignore the error. Type into it. This is not even remember. Oh, S. Okay, I should use S printer. Sorry, S printer. It does one value. We should have done this. So S printer does not give any value. Error. But you can actually say S name to this. No. And then we can actually run the test inside this. And yeah, great. You don't have to continue in this case. You just have to say return item and it will be returned and we will just stop here. We'll go to the next test, right? So we can also say fail now. This will fail now immediately, like all the test cases. T dot fail now. So fail now knows the function as having failed and stops its execution by calling run. Isn't runs all deferred calls in the current mode. Execution will continue at the next test or benchmark. Must be called from the go routine running the test or benchmark, not from the other go routine created. Okay, from the go routine running the test. Running created during the test. Calling fail now does not stop those other go routines. Okay, so this will only fail the current one. Anyways, I made it error and I just want to return it so that it stops so that we don't do more. So we have 0 and then we have 1. So both of these copies having problems. We just do this. is equal to make of then of test case dot input dot nums is going on, right? I'll just say dot nums and with that, let's see if that works. And test case, yeah. So copying does not have an error, right? So copying doesn't have an error, so we can just say this. I can just create a clone like this. One moment. There's an error. Okay, just call this as clone array and say test case dot input dot nums and say function clone array. I'm pretty sure why does it not okay, so clone array and bring this back. And you don't need these. You don't need an array, and call it array of integers, and then you just say array everywhere. Just give an error, return an error, right? You just say fmt printf error, right? Gives an error, so return error. So here, return, just say error, right? So we'll just call this as cloned array, right? And this is cloned array doing copy operation on input on array input, right? So we have clone array and we say input before processing is this. We actually have to return the clone array, so we'll have to do that. So it's gonna be this. Oops. And the array of integers, we'll say nil. This one will say clone array 1. And here we'll say comma error if error not equal to nil, and t dot error f or error, and then say error and say return, right? So we're just checking if arrays are equal, or else we just give an error. We build the array and finally we do this, right? So now I'm just going to run this again to check everything is fine. So things seem fine. So it's running test build array 0 and 1, and it says issuing process input is this, output is this. We expected this. Let's go ahead and fix this. So it's not going to be this way. It's going to be crazier than this. So first, let's go ahead and say the different things that we had planned, right? Is there a 13? Oh, there is a 13. So is there a 14? No. Let's create paperwork 14. And so we say that if index is equal to value is equal to value at index, value at index, then both are same basically, then runs of index is equal to value or is equal to index is equal to value. Okay, and then you just move on. You just do index plus plus. Right? Initial index is equal to 0, right? So initially index is equal to 0, and if value is the same, so just go on, right? I think the size, let me go and check for you. The length of this is greater than 1. It can just be 1 also. So maybe I can just write this code once and just do plus 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 plus. And if the value is equal, just move on, right? Um, for example, I can write 0, 1, 2, 3, 4, 0, 0. For example, test case, it says um, 0, and another one where it says 0, 1, 2, 0, 1, 1, 2, maybe bigger, right? So for these two, I'll just say let's go through the array actually, and or should we have to go through the array? Okay, let's go through the array, and if so, we can actually notice that these should be right. Let's run this. First two test cases should just pass it. Let's see. Yeah, the first two test cases just pass because how is that? Let's say nums of 0, nums of 0 is 0, nums of 0 is 0, so we just put that again and it just works, right? So this is fine. So as it is itself, it works. You don't need anything else, any other change in the code. But the next thing that we'll come up with will need some changes, right? So, so index plus plus, if index is not equal to value, then you say stop point, right, is equal to index, and stop point old value is equal to value, right? Once you do this, you actually go ahead and find out what is value. You actually say, um, you actually say the nums of index is equal to nums of value. Yeah, actually, so index has a value. You have already stored the value, so you just go ahead and do this, right? So you'll say nums of index is equal to nums of value because value was also an index. So it will go there, that index, you get that value, and it will put it here. You want this because nums of index is equal to nums of index, which basically gives this as this is value increments. Then so yeah, and then actually say as nums of index equal to value, right? And here you can actually say nums of index is equal to nums of index, and index is equal to value. So both are equal. So nums of index is basically value, right? So just say this index is value as nums of index is value, right? nums of index is equal to nums of index, right? Which is equal to as index equal to value, right? Actually, here we can say new nums of index, or just nums of index, or just say um, actually, yeah, we can just say new to understand that this is actually a new value that so this, right? And then here also we can say actually new. So as nums of index is value, right? And the nums of value you get some value, right? So you get that. So here this is equal to value and it's again value, right? So this is basically value again as this, and then you can also say something like is equal to, so this gives that this is right is equal to actually value equal to index. So that is that. So if it's not the same to do this, right? Just a moment. So once the values are not once the index and the value and the index are not equal, you do this. And you get the value. Finally, what you do is you actually say index you change it now to value. So once you change index to value, initially index was this. Uh, Actually, wait a moment. Index is index, and then you actually put this, right? So you can actually say something like this. You can say something like this. It will go into this, right? Or we can just say equal itself, and you store value in index, and then you keep repeating this whole thing. If index is not equal to value, I mean, if it's equal to value, then you go ahead and say I plus plus, is it? Let me check. Wait. So let's say it's one. Let's say it's zero, and zero it's equal. Next you have one, and you have actually two. When you go to two, you can't have two actually. Can be three maybe. So three, let's say 24. This is the index, and these are the values. So you stop. In this case, you stop. So you put index equal to value, and next index won't be equal to value. And if index is equal to the stop point, right? Then if index is equal to the stop point, you basically if index is equal to the stop point, what you do is you basically go ahead and what do you say? If index is the stop point, then you basically go ahead and do index plus plus and see if the next index value is negative or not. So you have to actually check if the values are negative, right? So one moment, you have to check if the values are equal, then the value is that. Values are equal, it means index is always positive or zero. So yeah. So if the value is negative, you can actually go ahead and so if value is negative, then value at index is negative, then index plus plus. Okay. And then later when it's equal, you do this. Then when it's not equal, you basically go ahead and do all the stuff. And then you put index's value. Before that, uh, actually, one moment. So initially you should have, I think, stop point as 0. And because or else you keep having stop point somewhere. You have to start somewhere and then you stop. So, hmm. You can start with the stop point as 0 maybe, like index 0, and stop point whole value is whatever is the value of at 0. And if we do end up, we will end up with index is equal to stop point, in which case we'll actually go ahead and put the new next value as index. So only after you're done, though. So let's say initially stop point is equal to 0, and initially, so the size is going to be at least 1, so we're going to have a okay value at index 0, right? And if the value at index is negative, then plus plus, right? And whenever there's negative, you just go ahead. And when the values are equal, you basically just put the value there, right? You don't have to do anything. Just go forward, right? The only thing is what happens when, let's say in this case, values are equal, like 0, 0. You start with index 0 and value 0, and the stop point is this. You'll actually have to update the stop point next because we started at, or you can call it as start point. So if if index is at stop point, you basically plus plus the index only after you reach. Hmm. You need to check the stop point only later. Okay. Let's see. I need to figure this out. Basically, stop point comes up over here when you check is it stop point. Once you put value into index, um, right, uh, we need to check if it is stop point and all. And if the value is negative, we need to actually go and check if it is also the stop. It's probably the stop point, and you need to get the value from the stop point old value, and then move on. So, so I'm just gonna go ahead and try this out in the next video. For now, I'll just stop and need to go eat. I'll see you next one. Bye.